Hello students, our next lecture in object-oriented programming is about templates. We will explain the basic concepts through simple examples. Templates are the fundamental parts of generic programming. In generic programming, the code is written without taking care of the data types. It acts like a blueprint for creating a function or a class. The same function or class will be able to deal with any of the basic data types. Templates are used for the code reusability and flexibility of the program. There are two types of templates: function templates and class templates. This is the structure or map of the function template. A function template starts with the keyword template, followed by template parameter inside the less than and greater than sign, followed by the function definition. So it is just like the normal function definition: return type, then space, then name of the function, and then list of parameters or arguments. And then we have the function body, and this is the starting bracket and this is the end bracket. And template is the keyword, class is the keyword. You can use the class keyword or you can use the type name, both are the same, it doesn't matter. And the list of parameters or argument and return type, they depend upon the requirement of your function. So when an argument of a data type is passed to a function, compiler generates a new version of the function depending on the data type. Template is actually not itself a function, it's a blueprint. The compiler uses the template to generate the type specific versions. The process of generating a type specific code is known as instantiation. The template is instantiated when we use it. A function template is instantiated when we call that function from any other function. So let's have our first example. This is our first example function template, and this is the keyword. This is the keyword. Remember, we can use class or we can use type name keyword. And this is the name of the template. The name of our template is CSC, and then we have the definition, function definition here. So normally we write the definition starting with the return type. Here the return type is void. The name of the function is sqr. Then we have a parameter. The type of the parameter is CSE. And then we have one variable. Again, the type of this variable is also CSE. So basically CSE will depend on the type of this template, and then result is equal to a multiplied by a, and then it will display the result. So in the main function we have two integer variables, two float variables, and now we are calling the sqr function. When we pass an integer variable to sqr function here, so the value of x is 5, so that means integer value is passed to the sqr function. So that means all CSC becomes now integer. So that means that this is integer a, that means that this is integer result. So integer uh, in the multiplication of two integers will be assigned to integer, and that will be the output. X, this one is x is 5, y is 10, and the square of 5 is 25. Now let's try to pass another integer variable y. So CSC becomes integer. This is integer now, this is integer for this statement only. So the output is the square of 10 is 100. For the third call of sqr, we will be passing a float variable. Now when we pass the float variable to sqr function, this all the CSC that becomes the float. So that is now float. So a is now float variable. The data type of result is now float. So float multiplied by float will be assigned to a float variable, and you can see the result that the square of zero point 0.2 is 0.04. Similarly, another float variable that will be passed to the function, and the result you can see the output. So that's what happens when we pass an integer value. This code becomes like this. It's the same code, but you can consider this code for the x or the y. When we pass the float variable to sqr function, these blue ends or the blue color text that becomes the float result, and then the whole definition or the type will be replaced with the float. And let's suppose if you pass the character, all these types will become character variables. Basically, when an argument of a data type is passed to some function, compiler generates a new version of that function, and depending on the data type. Template is not itself a function, it's a blueprint as we discussed in our previous slides. The compiler uses the template to generate a type specific version. For example, this one. For x and for y, for these two statements, the compiler will generate this type of code. The process of generating a type specific code like this one, it is called instantiation. Instantiation. A template is instantiated when we use it. This means that a function template is instantiated when we call it. For example, this one here, the template is instantiated. Here the template is instantiated, and similarly for these two. Here we have another simple example. Now this time the type of our template is, the type name is CSC, and the name of the function is display. So basically we will pass a variable or type of variable to a function, and it will display its value. So again we have two integers, two float variables, and two character variables. So for this statement, when we pass y, which is integer, so this CSC becomes a integer. So a is now integer, so integer will be passed and integer will be displayed. So 335. For the second statement, for the second call, uh, n will be passed, which is a float variable. Float will be displayed, and character will be displayed when you pass the character variable. So this is the simple function uh, using the different types of calls. This example is a bit different because we are using two templates. The type of actually this one template, but we are using two variables of the same template. CSC is the template, and one variable is A, the second variable is B, and the function receive A, and that would be displayed the value. Again we have two integers, two float, two characters. Now the first call, when we pass the integer, the that is fine, but when we pass integer and float, so the compiler will give you an error. And if you can see this one, integer and float, that's the problem, that's the error, because the type of x, that is a, and when you pass integer, that CSC become integer. When the CSC become integer, it also, this one is also integer, so you cannot pass a float value to integer variable. Similarly, when you pass n, so the CSC becomes the float. and if that CSC is float, so that means that this CSC is also float, so you cannot pass the character type. So when you are using two variables of the same type, remember that you cannot mix them in the same function. You have to write, or you can use separate functions for those, but in the same function, same type cannot be mixed with other data types. In this example, we are using two templates. The name of the first template is CSC and the name of the second template is CSC2. And then we have a function, the name is display, and we have two parameters here. The type of the first parameter is CSC, which is the first template, and the type of the second parameter is CSC2, which is the second template, and then we are displaying these value. Again, we have two integer variables, two float variables, and two character variables. Then we have two statements, and actually we are calling a display function twice. So for the first call for this statement, we are passing integer and float. So that means that for this statement, CSC that becomes integer and CSC2 that becomes the float. And for the second statement, we are passing float and character. That means for this statement or for the second call of the function, the a or the first template that becomes, or that is mapped to a float type, and the second template CSC2 that is mapped to character. So if you want to change the type of these, you can change, and according to your change, these templates or the types of these template will also be changed. The second part of our lecture is the class templates. So similar to function templates, a class template also starts with the keyword template followed by template parameter inside these greater and less than signs, then followed by the class definition. Writing a class definition for template is the same as we write it for normal classes. That means class keyword, this is the keyword, then space, then class name, then definition of the class is enclosed in the curly brackets and terminated by the semicolon. In the definition, we can have private, public, protected members, data members, member function as we normally write class code for our program. Here the template is it is the keyword again, and class is the keyword. And remember, we can use type name keyword instead of class here. It doesn't matter. So now let's have the our first class template example. This template is the keyword and this is the name of our template. This class, remember this class, it's different. It's the class template, and this class keyword is the definition of the class. So you have to be careful. This class is enclosed in these two signs. So the name of this template is A. Now this is our class definition, this one, the normal class definition, the one we used already in other programs. So the class item, it starts and it will end here. Then we have private members. We have two variables, rate and price, and the type of these two variables, it depend on the type of this template. So if a is integer, these two will be integer. If a is character, these two will act as character. Then we have two functions and both are public functions. The first one function in data, it will insert data into two variables, weight and price, and the second function, it will simply display the value of two variables. In the main function we have two objects, book and pen, and here you can see some additional code. That's actually we pass these argument, or we mention, or we indicate that the book object, the type of a, that will act as integer. For pen object, this type or a, that will be treated as float. So for book, weight and price will be integer. For pen, these values will be float. So let's execute and let's call the function book.inData. So we entered 1 1 and 2 2. Then we call book.showData. So 1 1 and 2 2 you can see on the screen. Then for pen.inData, we entered float variables, and then these float variables are showed by the show functions. So remember, for pen object, these variables, these become the float variables, and for book object, these are the integer variables, and as you can see in the result. For the same code, this time when I call the in data for book object, I entered 334.55, a float value. So what happened? You can see that the program was terminated, and that was the output. That is unexpected output, and you can see some garbage values here, because here in this function book.inData, the cn weight, this weight is expecting as an integer value, and I have entered here the float value, and that's why the program was terminated. So you have to be careful if you want to use this variable as a float for book also. So you have to write float here also. Similarly, if you want to use weight and price as the character variable, so then you have to write a character. Then both these value you can enter as the character variables. In classes, we can use two templates in the same fashion as we did for the function templates. Now I want to use for ID, I want to use the separate class, and for price I want to use the separate class. So here the type of templates, the first type is A and the second type is B. Now ID will be from this type and price will be from this type. In data, then we are passing two arguments to this function. The type of first argument is A and the type of second argument is B, and one is assigned to ID, or in other words, the type of A class, that will be assigned to ID, and the type of B class, because price is B, that will be assigned to the price. Similarly, these two values will be displayed on the screen. Now we have again we have two objects, the same two objects, the same names, the one we used in our previous example, book and pen. Now the book object, we are passing two arguments here, integer. So that means that for book, these two, A will be treated as integer and B or price will be treated as integer also. For pen, both variables, they should be treated as float and float. So you can see in the third statement here that book.indata we are passing integer and integer, so id is assigned to 4 and 44 is assigned to price. Both are integer values, fine. Then we have assigned float value to pen object, the second float value to pen object. The first float value that will be passed through this variable and through this argument. The second float value, the type will be mapped to this class and that will be passed to through this argument. Here in this example we are using two templates again. The type of the first template is A and the type of the second template is B. The type of the first template that will be assigned to variable id and the type of the second variable that will be assigned to price, because in data we are passing two arguments. The type of the first argument is 1 and 1 is from the first template and 2 is the type of B and that is the second template, and then we are showing the values of these variables. In the main function we have three objects: book, pen and pencil. So book and pen, they are both simple because we are passing same type of argument, integer integer and float and float. So we don't need two templates for book and pen. Actually, if you are using one template, uh, that one template can work for these two objects, but one template won't work for pencil because pencil is mixing the arguments. The first argument is float and the second argument is integer. So the type of first template means A, that will be float, and the type of second parameter, that will be the second template, so that will be integer for pencil or object only. So when we call the function and we pass integer integer, that will be assigned to id and price, and then we can show the result or display the result. For the second object, when we pass float and float, and then when we display the result, that will be displayed. For the third object, we are passing float variable and integer variable, and that is the value. Remember, if you want to have a fourth object and you want to pass character and float, so you have to write for example item and character, then float, and then name of the object, for probably bag or something. It's totally depending on the requirements. So you can mix the uh, type of arguments only if you are using two separate classes, because both this template and this template, they are separate and they are independent. So you can use the mixed type of arguments now. So we have the same program here with two additional statements. Again we are using the same two templates here. Now for the pencil object we are passing character as the first argument and float value is the second argument, and as you can see in the result that instead of character value we are getting 83. So what happened actually, the ASCII code of S, that is considered as the float value, that's why we are getting 83, and 0.03 which is a float value, that is considered as integer, that's why we are getting 0. So if you want to get the same value S and 0.03 here, so you need to change this one. This first argument should be character and the second argument should be float. But remember, then you cannot execute this one because here you are passing float and integer. So if you want to change it to the character and float, then you need to replace these arguments also. These are the advantages of templates. It provides a data type free coding technique, useful in generic programming, because you have to write a code and you don't want to bother about the type of the data, because the same function or the same template can work for any data type. Similarly, the same class can work for any data type. Good for code reuse. Of course, the same code you can use for integer, the same code you can use for float or character or any other data type. Useful to build powerful libraries. Greater modifiability. It gives you the option, if you want to use the template and you want to modify it for according to your own needs, you can do that. Beside the advantages, besides these advantages, there are some disadvantages also. For example, comparatively slower compile time, generates more code, support problem in few compilers, which reduce the portability, and it is difficult to debug. Uh, it, it actually generate more code because for the same template, if you call the same function using three different types, data types, so the compiler will generate three set of codes according to your function calls. So that's why it takes a bit more time as compared to the simple functions. So that's it for today, and see you in our next lecture.